All right, so we're just going to wrap up our discussion on hole inspection gauges. I hope you found the two videos previously very useful, and uh, we're just going to continue comparing all of them and some tips for all of them. So first of all, whenever you're using a hole inspection gauge, it's going to register on 2 points or 3 points, with the exception of the pin gauge, which is pretty much going to check all points, but the other ones are going to check 2 or 3. And just remember to rotate that gauge uh, radially so that you're getting the full picture of the part, as well as axially going up and down. Um, because you need that, like I said, you need that diameter to be in tolerance at all places, not just the one place you checked. If it's fine where you checked it, but it fails somewhere else, rotationally or axially, well, the part's not going to work for the final customer or the assembly. And then remember, when you're taking a look at these gauges, or sorry, your parts, surface finish is going to have a big effect on some of these gauges. Even the pin gauges, if it's a rough surface, it's going to be hard to get the pins through. The needles on some of the on the dial gauges are going to be affected by that. So generally speaking, you want to give these things a good finish. Otherwise, use a caliper. If it's got a bad finish, I mean, why bother? You could use a caliper because if it's got a bad finish, it's probably not a precision hole. But one more thing. Let me see if I have the graphic. No, I don't have the graphic. So one more thing. They have a graphic in another video. Um, when you are checking, the reason I say always check multiple places is because as these diameters, if you have a rough diameter manufactured quickly, or maybe it's large, even though you're expecting this nice round perfect circle, in reality what many processes end up doing, this is an exaggeration, but you'll get some high points, you'll get some low points, you might even get something that's not symmetrical. You might get, just kind of freehand a blob, but magnifying the air, you might get something like the red or the blue. You might get something egg-shaped. And this is why if you check, if you check this diameter versus this diameter, you'll see a difference. And you'll just have to figure out, is that difference still in tolerance? Is the high points and the low points still in tolerance? A pin gauge, one of the reasons I love the pin gauge is it doesn't check just a few points or 3 points. It checks the entire surface. So if that pin gauge doesn't fit in the red circle, because there's a little collapse here, it's elongated here, well, it doesn't fit if your go pin doesn't fit. So that's why I like pin gauges. And that's one of the reasons I keep reminding people, check multiple places. Because I've worked with a lot of people who only check one place, and that one place is in, but another place on the diameter is out. So all right, so let's go back to the presentation, our little summary. Apologize for technical difficulties. Okay, so we talked about checking multiple places, and now if you're going to do a comparison of size, and you just wanted like, is it even, is the size of the range even capable of the chart? Is the gauge even capable of measuring the part? Well, here's a quick little comparison. If it's less than 6 inches, pretty much everything's going to do, less than an inch, everything's going to do it except for the tubular mic. The tubular mic's not going to get small enough to measure less than an inch. if it's between 1 and 6 inches, you're no longer going to be able to use your gauge pins without something custom. But you will be able to use hole mics, telescope gauges. Around 4 inches or so, 3 inches or so, you'll be able to start using these tubular mics. And you'll still be able to use the dial bore gauge, the dial hole gauge. Actually, you won't be able to use the dial hole gauge. That will drop off too. A caliper and a CMM. And as you get bigger, you're going to see more of these gauges drop off. So if you're doing between 6 and 12, the main gauge there is going to be the tubular ID mic. Or the dial bore gauge. You know, some of these can get pretty big anvils. But as you get larger and larger, more of these things drop off, and you have to start relying on a caliper or a CMM because those are the two biggest pieces of equipment you have out there, and maybe the tubular mic might stop around 36 inches. When you start using a big caliper, as I mentioned in the caliper video, the larger that these get, the more accuracy problems you have. So it might even be plus or minus 4 thousandths or 5 thousandths because it's such a huge caliper that it can't maintain that accuracy. So, and sometimes a CMM isn't practical. You know, you can be tempted to just throw everything on a CMM, but part may be too big for your CMM. You may need to get it on the machine, you know, get the measurement on the machine, because if you take it off the machine, you can't remachine it if you need to. So it's not always practical, which is why you might need to get better with some of these gauges. Now, when it comes down to what's the best gauge for the job, this is kind of apples to, you know, all things being equal, apples to apples. If you had your choice of everything for one part, I would say gauge pins are your best bet. That's assuming you have the go and the no-go, obviously, but it checks 100% of the surface is in tolerance or not. It's not registering on just a few points, and it's very quick. It's very fast. It's easy to duplicate. So that's my number one choice is a go and a no-go pin. Next up, I would say the hole micrometer is the easiest and most accurate of what's remaining. It self-centers. It's got great accuracy. It's got a ratchet stop. The downside is very small increments. This increment here is 0.8 to 1 inch. Only 0.2 of an inch of range before you have to get another micrometer. So that's the downside, but they're really worth it if you've got some bores above an inch that are probably between 1 and 2 inch, reasonably priced. Between 2 and 4 inch, still reasonably priced, although getting pricier. Above 4 inch can be pretty expensive. But again, it's got that vernier scale resolution. It self-centers, and it's a direct measurement. There's no need to use any other devices. Next up, dial bore gauge. I would say, despite the setup issues, if you can master the setup issues, then the accuracy that the dial indicator offers you is great. It is a great range. In the set of 3 that I have in the case here, it started, I think, at 0.7 inches, goes all the way up to 6 inches. So that's a great range. And good resolution on the dial, good accuracy. Downside is as you saw, it's very tricky. The tubular inside mic would be my next choice, mostly because it has a great range, and if you really wanted to use the vernier scale, I mean, you certainly can to get yourself in the ballpark. You'll want to check it first. If you've got a ring or set up some Joe blocks or a micrometer, check the accuracy of your vernier scale, and then you can take it to a part and at least get yourself in the ballpark without using another mic. But anytime you are going to measure for accepting it or rejecting it, grab the corresponding OD mic that will be in the right size to measure across this. One of the downsides, again, it takes a little experience, as you saw me, to master getting it in there and twisting it around. But Otherwise, I've used these a lot. I've gotten good results with them when I had some large parts. My next choices would be a telescope gauge and a small hole gauge. Really, I mean, they're certainly fine for what they do. Here it is. Telescope gauge and a small hole gauge. But they're transfer gauges. These, on the small hole gauge, the anvils are pretty flimsy. I can very easily over tighten it and not realize it. With the anvil gauge, the locking mechanism can be a little flimsy, and getting it in there is tricky. So, when I have other easier gauges to work with, I would. And then, number 6, your caliper, your CMM, your other specialized equipment and attachments. It all depends. Sometimes the CMM might be the first choice, and sometimes the CMM might be the last choice. I'm not going to throw every single thing on my CMM just because it is the most accurate compared to some of these other ones. But if I can do the job with a simpler, less expensive, quicker check, which a lot of these are going to be compared to a CMM, I will. So it's always that trade-off with a CMM. Is the automation worth it? Is the extra time to program it worth it? If I spent, every program I've ever written has at least taken an hour, a decent one that has a little complexity, an hour to 4 hours programming a part. Is it worth it, or should I just grab the part and check it with the mic and be done in 5 minutes? And the next time it comes around, I'm done in 5 minutes, right? So it's always a trade-off. You got to think about that. Hopefully these videos show you some possibilities. Think about the accuracy. Think about the tolerance zone. Always be thinking about, always be deciding based on your print. Use your print to guide your decisions. We talked about 6 to 8 different gauges in this this whole inspection video. So remember, I mentioned the accuracy of some of them. The transfer gauges don't have a stated accuracy, but use the print. The print may override, and help you make that decision if it's a tight tolerance spec. So always be using your print to guide your decisions. And here's my summary. There's a wide variety of methods and gauges. As you can see on the table, it's overflowing. The driving factor in any inspection, whether it's a hole or not, when you have to make a decision about which gauge to use, it should be the tolerance zone. So on your print, whether it's called out specifically on the print or it's just your title block tolerance, just get in the habit of comparing that zone to the accuracy of your gauge, which is called uncertainty ratio. And I've got a video all about that, which you can watch. I recommend you watch, and it'll help you make those decisions. Over time, you'll get a feel for when you can use a caliper, when you need to use a pin gauge. I will use a caliper for a lot of these holes if they're open tolerance because it's fast. I don't have to grab the go and the no-go and verify that they're okay. But on the other hand, if I had 20 of these parts or 50 of these parts that I needed to inspect, well, then I might grab the go and the no-go pin because it'd probably be faster than doing this all the time. Comes down to that trade-off of speed and accuracy. As I mentioned many times, I think the solid pins are the way to go for anything less than an inch. If you don't have them, see if you can get them. If you're working with tight tolerance stuff, even if you're just working with open tolerance stuff, it can be fast. They're easy to use. They're not going to really damage the part as long as you're sliding them in smoothly. Some of these other gauges, too much pressure, rubbing it, it can cause some problems. So the last bullet point there, practice makes perfect. As you saw, I struggled with some of these gauges that I don't use every day. And some of these other ones that I use all the time, I got through it very quickly. I couldn't even really show you how to use it wrong. It's so much muscle memory on some of these gauges. So practice makes perfect. If you're struggling now, don't worry, it'll get easier the more you use it. I'm sure if I use the dial bore gauge every day, it would be a lot easier for me to set up, but it's not something I've done. So just keep practicing. And thank you for watching this series of videos on hole inspection. I appreciate you taking the time. I hope you enjoyed them. Please check out my website, pragmaticmetrology.com, for more videos covering a wide variety of gauges and especially the concepts that go along with understanding some of these gauges and performing inspections. Um, and again, I always close my videos by thanking Delaney Machine College because I could not do these videos without them providing parts and tools for me to work with. It's a great program, the machine technology program in Oakland at Laney Community College in the Peralta district. They've got classes on manual machining, CNC machining, inspections, mechanical drives, CADs, CMMs. It's a great program if you're in the Oakland Bay Area and you want to advance your career. Definitely check them out. They've got machining certificates and apprenticeships that they're in contact with local manufacturers. It can be a great career move for you to put this on your resume as well as make some connections with people in industry. So uh, check them out and please check out my website for more videos. I hope you liked it. Thank you and I'll see you next time.